Hello Year 12, today we are looking at cumulative distribution functions. So these are the dot points that this covers. I'm not going to go into too much detail, you can read them yourself. And we're looking at cumulative distribution functions, otherwise known as CDF. So the cumulative distribution function is a general formula for finding probability of x is less than or equal to x directly. The cumulative distribution function is given by capital function of x equals the integral of a to x of fx dx. This is where y equals fx is a PDF defined in the domain of a to b. This is where a PDF is a probability density function. So we have our first example, and it is a continuous probability function is given by fx equals 4x cubed over 255, defined in the domain of 1 to 4. And we want to find the cumulative distribution function. So what this is fx equals the integral of a to x of fx dx. So this is where we have that our fx equals 4x cubed over 255. Our a value is equal to our smallest number in the domain, which is 1. And we're unsure of what our x value equals. It just stays x for the time being. So what this equals is the integral of 1 to x of 4x cubed over 255 dx. Now we need to take out the common constant, which is the fraction of 1 over 255 of our integral of 1 to x of 4x cubed dx. So what this equals is the integral of 4x cubed is 4 to the power of x. So we'll have 1 over 255 bracket x to the power of 4 with the interval of 1 to x. When we substitute this in, we get 1 over 255 of our x to the power of 4 minus 1 to the power of 4. So we get x to the power of 4 minus 1 over 255 to be our CDF function. So for this, it's important to note that we just ignore the upper limit of our domain. We only really want to know what our lower limit is because we're going to put numbers into that upper limit later. And we want our CDF to be in terms of x. So now we want to use the CDF to find the probability of x is less than or equal to 3. So we have our fx is equal to x to the power of 4 minus 1 over our 255. So this is what we just found. And for the probability of x is less than or equal to 3, we sub in 3 where our x is. So we get 3 to the power of 4 minus 1 over 255. We put this into our calculator. So 3 to the power of 4 is 81. So we'll have 81 minus 1 over 255, which is equal to 80 over 255. And 80 over 255 does simplify down to be 16 over 51. So therefore, the probability of x is less than or equal to 3 is equal to 16 over 51. Then we want to find the probability of x is less than 1.6. So we do the same thing. So for fx equals x to the power of 4 minus 1 over 255. We sub in 1.6 where we have our x. So it'll be 1.6 to the power of 4 minus 1 over our 255. So 1.6 to the power of 4 minus 1 over 255. So we have 1.6 to the power of 4, minus 1 over 255 gives us the answer of 0.021778 0.8253, and that equals 0.0218 to 4dp. So therefore f of x is less than 1.6 is equal to 0.0218. So then we use the cumulative distribution function to find probabilities such as the probability of x is greater than or equal to a, or the probability of a is less than or equal to x is less than or equal to b. So for a continuous probability function, it is given by the probability of is given by fx equals 3x squared over 335, defined in the domain of 2 to 7. So we want to find the cumulative distribution function. So we do exactly the same as what we did before. So we have f of x equals the integral of a to x of fx dx. And this is where we have our fx to equal 3x squared over 335, and our a value equals 2. So we'll have this equal to the integral of 2 to x of 3x squared over 335 dx. We take out our common factor or common constant of 1 over 335, the integral of 2 to x of 3x squared dx. So what this equals is 1 over 335. The integral of 3x squared is x cubed with our limit of 2 to x. We then sub our limit of 2 to x in, so we get 1 over 335 bracket our x cubed minus 2 cubed. We're in our room, so I'm just going to come up over here, equals 1 over 335 bracket x cubed minus 8. So then what we need to do is put this all over. So we'll have x cubed minus 8 over 335. And that is what our fx equals, or our cumulative distribution function. So now we want to use our CDF to find the probability that x is greater than or equal to 4. So what we have to do is we need to find fx is our x cubed minus 8 over 335. And what we need to do is find out when it's less than, and then because we're talking about the area under the curve equals 1. So then we'll go 1 minus the probability that x is less than 4. So we have the probability that x is less than or equal to 4 is equal to when we substitute 4 into f. So it will be 4 cubed minus 8 over 335, which equals, so 4 cubed minus 8 divided by 335 is in fact equal to 56 over 335. And then as the area under the curve for probability density functions, curve is 1, we have that the probability that x is greater than or equal to 4 is equal to 1 minus the probability that x is less than or equal to 4. So what this equals is 1 minus 56 on 335, which equals 1 minus 56 over 335, 279 over 335, and that is our answer. Now to find the probability of 3.5 is less than or equal to x is less than or equal to 6.2, what we have to do is what this equals to, so the probability of 3.5 is less than or equal to x is less than or equal to 6.2. It is the probability of x is less than or equal to 6.2 minus, I'm just going to move this across a little bit, minus the probability that x is less than or equal to 3.5. So that is what we're calculating. So we need to find the probability of both these things. So we substitute in 6.2 for when we're finding the probability of x is less than or equal to 6.2. So we'll have 6.2 cubed minus 8 over 335 minus the probability of x is less than or equal to 3.5. We sub our 3.5 in to our CDF. And so what we get here, 6.2 cubed minus 8 divided by 335 is 0.687462687 minus, when we sub in our 3.5, so 3.5 cubed minus 8 divided by 335 is 0.1041044776. So what this equals is, 6.2 cubed minus 8. It is equal to 0.58344171, which is equal to 0.583 to 3 decimal places. As the question doesn't ask what the decimal place is, you can just round to what you see fit. But 3 decimal places is good for this question. Okay, moving on, we have a mode of a continuous probability distribution. So we sometimes want to know what the highest probability is. This is called the mode. So the mode is the maximum point of the probability density function. So for our examples, we want to find the mode of the continuous probability distribution shown below. So we want to find where the highest point is. So to find the highest point, it would be roughly here. Okay, so we can only estimate. So for this, the highest point of the PDF is at x equals 7.8. So the height, or 7.7 even. So for these ones, you can only guess or approximate where it is, as we don't have like a scale behind it in order to see it clearly. X equals 7.7. So the highest point of the PDF is x equals 7.7. So therefore the mode equals 7.7. So that's looking at it graphically. Then if we were to look at a continuous probability function, work it out, and then find the mode, we have to do this. So a continuous probability distribution is defined on the interval of 1 to 5 and has an equation of fx equals 3x bracket 6 minus x all over 92, and we want to find the mode. So what we have to do for this is we have our fx, and we're trying to find the maximum point. So when we were trying to find the maximum point in calculus, we had to find the stationary point. So we have fx is equal to 3x bracket 6 minus x over 92, which is equal to 3 over 92 lots of 6x minus x squared. So to find a maximum point, turning point, we have to differentiate for this. So we'll find f dash x. So f dash x is going to be 3 over 92, stays the same, and then we differentiate inside the bracket. So it will just be 6 minus 2x. And for stationary points, we let f dash x equal 0. Okay, so this is bringing back some of our calculus knowledge and I suppose integrating the topics together. Okay, so when we let this equal to 0, we multiply the 3 over 92 to the other side. So we get 6 minus 2x equals 0. So we'll have 2x equals 6, x equals 3. And we have to check whether x equals 3 lies in the domain. So as x equals 3 lies in the domain, it is a possible maximum. We do, however, need to check that it is a maximum. So we have to find the second derivative. So f double dash x equals 3 on 92, bracket -2, which equals 3 on 92 times -2 equals -3 on 46. And so because it's less than 0, concave down, therefore x equals 3 is a maximum. Therefore, the mode equals 3 for this continuous probability distribution.